Okay, guys, so there is still some parts that we haven't finished with the previous section, but I will return to them just a little later. Here, let's understand what is meant precisely when we talk about the precise definition of the limit. So when we evaluate a function at some point C, the analogy you should think of is very simple. You plug into the function one point, one particle, and then this particle is projected onto the y-axis. So for example, if the function f of x were x squared and c were, let's say, 2, then 2 will be projected to what point? What would be that point over here? Please respond in comments. 4. Thank you, Carolina. So it would be 4. That's what happens. You just launch one particle. What do we do when we calculate a limit? When we calculate a limit as x goes to c, we do not actually plug in c into the turret. We are plugging this. We have this pipe. We open up a pipe of some radius, in this case delta 1, and we put a lead on c, and we launch all the particles within that pipe, this horizontal blue pipe, and each particle is launched from the x-axis and lands somewhere on the y-axis. Do you see that? Now, what you have is this dynamics. You are going to squeeze and make the pipe on the x-axis narrower, and that will hopefully make the stream more and more centered about the point L. Okay, and then how do you make this idea precise, centered around, so centered around the point L? It means that as you center the stream, the input stream around C, the output stream will be centered around L. Good? What that means is, suppose we open a vertical pipe around L. So the vertical pipe is of some particular radius epsilon. Okay, that's just whatever the opening. Epsilon might be a pipe of 1 inch opening, in that case epsilon is 1, or it might be half an inch opening, in which case epsilon is 1/2, or 1/4, etc. But the idea is this pipe is generally supposed to be very narrow. And then your goal in this game is to close the valve enough, the horizontal valve enough, so that the stream will entirely land into the pipe. Does it make sense? So for example, here for this epsilon, I first attempt delta 1. And this delta 1 does not work. Why? Because you see some particles do get into the pipe, but other particles, I think of them as water particles, they fly onto the wall. Are we there? Are you there, guys? Alexa, are you with me? Wonderful, wonderful. Thank you. And again, guys, I doubt that me mentioning that many times, asking you to show your faces will cause you to show your faces. I have much more sinister intentions for the future to make you do that. But please, before I become very sinister, show me your beautiful faces. Okay, thank you. Good. Where are we? So then I try another delta. You understand? So the idea is very dynamic. What you are doing is you are closing up the valve, and the input pipe gets narrower and narrower, still focused and centered at C. You see there is a lead on C so that I don't put it into the hopper of this function. And I hope that the water current is going to enter the pipe. So delta 2 still does not work because although the stream is narrower, some points, some particles land outside of this interval. Good. And then maybe I try some delta 3, I make the interval even narrower, and then the entire current goes into this particular pipe. Now the idea of delta epsilon is that I can make this procedure work for any pipe. You follow me? That this red pipe, this output pipe, no matter how narrow it is, I will be able to squeeze delta small enough. I'll be able to create a pipe on the x-axis that is thin enough that the current will hit within this range within, basically that each particle will fly and enter the pipe and not miss it. Do you follow my explanation so far, guys? If so, let's say, please write from just what I say, so here. So write yes, and I will know if you follow the explanation so far. So you will have to have quite a lot of imagination here. Okay. Well, I hope that means that the other people that have not responded, that they follow it. Okay, thank you, Carolina. The idea of delta is not entirely clear. Okay, so guys, always ask me and don't be shy about it, right? This is something that hopefully you will understand perfectly by the end of the lesson, but it takes some time to imagine what happens here. What happens when we take limit? And forget about definitions and complicated evaluations. What happens is that we are plugging in imitations of the number C, and we should get imitations of the number L, okay? Now, imitation means that we actually don't necessarily get values like L. If I don't put C in, maybe, well, if I put something around C, I might not get L exactly. I'm not sure what will happen to C. Maybe C is mapped somewhere else. Limit does not mean the same as calculation. So how do I try to make this idea very precise? So same as L means whatever is controlled by epsilon. Same as L means specify how close do you want the outputs to land within L. So that means you specify this horizontal, this pipe on the vertical axis, on the y-axis, centered at L, and the radius of this pipe is epsilon. Okay, so that will tell you the measurement of closeness that you have for L. And then for that measurement of closeness, can you make values close enough to C so that all the close values near C get mapped into this region for L, for this particular closeness, for this particular epsilon. And you must not be able to do that just for one epsilon. You should be able to do that for all epsilon. And then what you do is you squeeze this input interval. This input interval will have a delta radius always, right? So this delta has to be small enough so that all particles will end up flying into this pipe. So this is, you see, the smaller the delta, the better are the approximations of C, because you see points on this interval are points that have a particular approximation to C. So delta 1 tends to be like your standard. How good are the approximations? The worst approximation is near delta 1. Good? Near delta 1. See, that's the worst approximation. So this gives you an estimate of how good are your counterfeit C's. Here the counterfeit C's are a bit better. Yes, Carolina.
Sorry. Are you normally provided with what that range should be?
Yes, but the point is normally you're supposed to construct a procedure that will be able to hit. So basically you're like an artillery person, right? You are like an artillery lieutenant, and your hope is to get the particle to always land within the pipe, no matter how narrow is that pipe. You understand? So somebody specifies, here is my pipe, that's my output pipe. The water current, every single particle has to go into that pipe. And all you can do to control the current is to make the input current, the horizontal, the delta current. You see, delta means how good is the approximation to C, or the radius of the input pipe, the blue pipe, right? You can make that pipe as narrow as you like. So you make it as narrow as you like, and you hope that by doing this, it will cause the particles to fly all into the focused range, into this epsilon size pipe. So you cannot possibly specify a number, because if you were able to do it for epsilon equal to 1, maybe you will not be able to do it for epsilon equal to 1/2 or to 1/3. The smaller the epsilon, the narrower is the pipe, and the more difficult it is to do so. But the idea is that if I can specify delta as a function of epsilon, in other words, give me any pipe, I will tell you what procedure to employ. How do you narrow down the input current so that all the particles land where they should? Make sense?
Yeah, thank you.
Wonderful. Okay, so for this particular epsilon, this particular delta 3 seems to work. So delta 1 that I tried did not work, delta 2 failed to work, but delta 3 worked perfectly. Okay, and maybe for a smaller epsilon, I might still change the valve. So that's pretty much the idea of the definition. Okay, so this is again, right? So you can control the input pipe, how wide it is, and the output pipe, its width is given to you. Cool? So this is how the definition looks like formally, and hopefully you will understand this. So you don't read the algebra, you read the meaning. So we say that limit as x goes to c of fx equals to L if for every epsilon there exists a function which is delta of epsilon such that the absolute value fx minus L can be made less than epsilon whenever x minus c is less than, its distance is of x to c is less than delta of epsilon. So what is this really saying? Very simply, L is your target, right? F of x is where the particle actually lands. So for example, suppose that you start, here is a particular x, right? This is a particular x, it's fed in here and maybe flies right over here. So the distance of x to L is going to be more than epsilon. You see, this wing is the length epsilon. So this particular x flies out, f of x is here, and f of x minus L is bigger than epsilon. Not this delta does not satisfy it. Of course, some smaller, some closer, the x to c, like this one, might be flying right into the pipe, so that works. Okay, but here, no matter what x I pick, any x I pick, it's flying to whatever position. Let's say maybe it flies over here, and the distance between this point and L is less than the length of the wing. And the length of the wing is what? It's L plus epsilon minus L, which is just epsilon. Or if the point lands below L, then f of x minus L is negative, but if you take absolute value, that will give you the distance. You understand? So this is just a way to talk about the pipe in terms of distances. So I know the point landed into the pipe if the distance of the point fx to the center of the pipe is less than the radius of the pipe. Make sense? And that is achieved whenever x came out of a pipe around c of radius delta epsilon. Okay, so if it came from this pipe, then it's entering where it should go. Good. So here is my first explanation of a delta epsilon argument. We'll do it together, and then you will try a similar example on your own. Sounds good? So, okay, guys, here is that example. Use delta epsilon argument to show that limit as x goes to 2 of 3x minus 1 is 5. Okay, how do we do that? So here is that argument. What we do is we think in reverse. Imagine that what you did, guys, is that you were busy turning the valve, closing the valve, and making the pipe, the input pipe, thinner around C. And then suddenly you were successful with the particular epsilon that you were assigned. And the question that you are trying to answer is then, how tightly did you squeeze the valve, the input valve? Okay, you want to know what was the distance between x and 2 in this case to achieve that f of x, which in this case is 3x minus 1, is within epsilon away from 5. Okay, so this is how I do that. And I'll ask you a few questions afterwards to see if you follow. So let's pretend that 3x minus 1, where the particle actually landed, and its target 5, the distance between them was less than the radius of the target pipe. So 3x minus 1 minus 5 in absolute value is less than epsilon. The question I want to ask then is, how close was x to 2? I want information about x minus 2 because x goes to 2. Okay, so here is how I work it through. So epsilon is bigger than 3x minus 1, which is 3x minus 6 in absolute value. Now I factor out the 3. So we have 3 times parentheses x minus 2. And what I can do is I can just take the 3 and I divide. And I have that x minus 2 is less than epsilon over 3. So what does it mean about the relationship between the input pipe and the output pipe? In very, very simple, very human words, if you could possibly, you can either type in a sentence or maybe you can actually talk to me.
Yeah, what was the question?
The question is this. We found that delta, you see, I was able to say that here is what my calculations did as follows, right? If the particle, which lands at 3x minus 1, was within epsilon away from 5, that means that 3x minus 6 is less than epsilon, which means that the distance between x and 2 was less than epsilon over 3. So I can take this to be my delta. So if epsilon is my radius for the target pipe, delta of epsilon can be taken to be, in this case, epsilon over 3. What does it mean in terms of the relationships? You see, so this tells me what? In order to heat within a pipe of radius epsilon, how much, well, in this pipe, how much must I narrow the input pipe to accomplish that? Do you follow what I'm saying, guys? My question is just, do you understand how this worked?
It would,
Go ahead, Carolina.
I don't, it has to be so what you're saying is epsilon is that range, and to get into
It's
the
the
range,
radius of the pipe, yes. So it is the radius of the target pipe.
so that means whatever your input value is, that the absolute value of the input minus 2 should be less than the epsilon, like, divided by 3.
Yes, and then what's the relationship between the pipes? Just very human type. You see, so you're a plumber here, right? So you're said, okay, make sure that the current enters into this pipe, right? And this is the pipe that you can make as narrow as you like. How? What's the comparison? This input pipe has to be in what relationship to the output pipe, so that the current will be launched by the gun and enter into the output pipe. You understand what I'm saying? It's what you're doing here. You are engaged in ballistics, like a water gun ballistics. You have a pipe, and then there is this gun, and the gun is supposed to shoot this water into the target pipe, and all the water has to enter that pipe without any splashes landing outside of it. Make sense? So what's the relationship between those two pipes? A very, very human word. You see, this is just, it's called, you translate it. What is that relationship? Between this pipe and that pipe, what is the relationship between them? That's my question.
Relationship meaning, are you talking about the number within the set, or are you talking about just that one feeds the other?
Relationship. So so is the input pipe smaller or bigger than the output pipe? Can the input pipe be smaller? Or so can the input pipe be bigger than the output pipe, and it works?
Isn't the input smaller?
Yes, by how much smaller? So if the output pipe is 1 inch wide, radius is 1 inch, the input pipe has to be smaller than what? Equal or smaller than what? What's the radius? If this is 1 inch, then the input pipe has to be of radius what? You understand my question, guys?
I mean, would it be epsilon over 3?
Yes, which means, thank you, Alexa, which means what's the relationship? Well, Rachel says 1/3 of the target. Yes, that's my point. It must be 1/3 of the target. You understand, guys? When you read this thing, it should not be empty symbols to you. To me, it reads this way. In order to accomplish this for this particular function, I must ensure, whatever is my target pipe, I must ensure that the radius of the input pipe is 1/3 the radius of the output pipe. That's what the epsilon over 3 means. Delta of epsilon just tells me how to adjust the input so that the current enters into the particular pipe. You understand? And since I can accomplish that for every pipe, if the pipe is of radius epsilon, means whatever radius you specify, I can win this game by making my domain radius 1/3 of that radius, and then the water current flies up and into the pipe. Now, and nothing escapes. Make sense? You understand why that is a proof of limit? Because you speak about comparing. You see here you're mentioning how good on the delta mentions how good must the inputs be to satisfy this tolerance of error, right? Epsilon is a tolerance of error for how L-like are the numbers that you get. You understand what I'm saying, guys? L-like is this, right? So when you say X goes to C, that means as I plug C-like numbers into my function, I get L-like numbers. What is L-like? L-like numbers just means that the values that I obtain, are within a particular pipe, right? So L-like means that it's a very subjective thing. What is L-like? So if your calculator can calculate numbers maybe up to, if it's a scientific calculator, maybe 8 digits, correct? So your epsilon will be maybe 1 over 10 to the power of 8, okay? A small number, right? Or 10 to the power of minus 8 is the tolerance of a calculator. Beyond that value, the calculator does not understand any difference, right? Everything that is different by an order of 1 over 10 to the 9 or smaller, then the calculator, let's say, does not show you the difference. You cannot tell it apart, okay? So in this case, L-like is whatever the epsilon. And the idea, of course, mathematically, you can make epsilon smaller, and that means that your ability to detect if something is L or not L is better. So the idea is no matter what's your ability to detect L, if your ability is at your particular resolution. That's another way I explain it, by the way. If you're interested, I can show you, right? That's an advice for dating. How do you know if you're dating something wonderful or a monster, for example? Or that I do using delta epsilon as well. Okay, but this explanation, the plumber explanation that I give you here, is here I specify tolerance for what is L-like for me, and here I specify the tolerance of what C-like. Okay, so that means what? That means that if L-like is tolerance is epsilon, then I need to know how close are the inputs to C, how close must they be to always get to within the tolerance. You understand? So it's like a detector. If a particle lands outside of this interval, that particular detector is going to say, well, I get values that not all of them are the same as L. But if it gets into this pipe, the machine thinks it's L. Okay? And a better machine will select a narrower pipe. It would be thinner around L. So if I can do it for every machine, every detector eventually will tell me that there is no difference. You understand? I'm conveying this idea. Dynamically, I squeeze the input pipe, and what should happen is that the current is focused around L. So if it's focused around L, it will enter any pipe centered at L, no matter how thin. You understand? So that's the epsilon that I'm trying to communicate. Make sense? That's the idea. It was Kosh's idea, but the explanation in terms of water cannon is mine. I hope you like it. I was proud of it at some point, when I could still be proud. Good. So here is again, right? So if epsilon in that case was 1, I have to select delta, which is 1/3 or smaller. I can always select smaller input pipe, but the delta of epsilon equal to epsilon over 3, that gives me, if I select it wider, maybe I will cause some particles to go farther than I want them to be. Okay, if epsilon is 1/2, I have to select the delta to be equal to 1 over 6, etc. So here is your challenge, guys. You see, now you have to do the same thing, but now on your own, you have to prove to me using delta epsilon argument that limit as x goes to -2 of 5x plus 2 is -8. Go ahead and try to do this. When you're done in the comments, you can tell me what you think delta might be in terms of epsilon. Okay, we have our first contendant. So x plus 5 less or bigger than epsilon over 5, James? And guys, you can give me the answer, by the way, by just mentioning what's delta.
It should be less.
And x goes to -2, by the way, right? X approaches -2. So I need the distance between x and -2 here, right?
Okay. Yeah.
Good. Thank you, James. Okay, we have a few people. Delta is epsilon over 5, Rachel. Minkowicz, by the way, there is Minkowski's inequality, a very important inequality. Maybe we mentioned it actually below. And okay, good. So we'll test, guys. You see, some of those questions are easy enough for you to be able to answer them and still not understand what it's about. Those questions are just toy problems. I want you to understand what is this about, really, right? Delta epsilon is the important idea.
Professor, I ended up making a chart, which I don't think I was supposed to.
Okay.
And I was, what exactly are we trying to find again?
Okay, well, thank you, by the way, for talking again, right, as always. And tell me, to the best of your ability, what is it that we're trying to find?
Well, we're trying to find, whether it's less than or equal to 8?
Well, you
Or
see, less than or
epsilon?
equal, it's confusing,
delta?
right? When you say it's, what is the it's? It's less than or equal to a, right away you forget. First of all, image, right? What's the picture?
Mhm.
I'm not having any formulas in my head. What I picture is, maybe if you understand what I try to picture, maybe you picture the same thing. What am I picturing?
Cannon.
Sorry?
The cannon?
The cannon. And the cannon is squirting water from the input pipe into the torrent, and out of the torrent into the output pipe. Yes?
Mm-hmm.
Make sense? Epsilon is the output pipe, right? Epsilon is the radius of the output pipe, to be precise. Make sense?
Okay, so the FX?
So what I'm trying to do is this, right? The claim is, forget about any delta epsilon for a moment, right? The claim is what? The claim is that if you select whatever pipe on the target, and the target is -8, so the pipe is centered around -8. Here is the opening, here is the -8, yes?
Mm-hmm.
Then I can close the valve around -2, and so that the current of water goes right into the pipe. Nothing is spilled out, right away. Everything goes into the pipe. Make sense?
Mm-hmm.
Nothing hits above or below the pipe. Okay. So by that I need to do what? When I squeeze in, I change the radius of the domain pipe, the delta, right? So given an epsilon, I want to say what should be the delta, so that if that's my width of the pipe on the x-axis, then all the current is going into the target pipe of radius epsilon. Okay. And you see why that's supposed to capture this limit idea, right? It's because epsilon, the narrower the target pipe, the more the better is the approximation of L. So everything here, you see, it's more and more like L. So the narrower the pipe, the harder it is to hit into it. The idea is that if you squeeze the target pipe, the domain pipe thin enough, then the current will be thin enough to hit even in here, even if the target pipe is very, very narrow. So what you try to do is you don't say narrow pipe, you say for no matter how wide is the target pipe, I can make the input pipe narrow enough. And narrow enough means in terms of epsilon, right? Because if I know this width, I need to know how, in relation to this width, how to order to narrow the input pipe, okay? Narrow the input pipe enough so that the current goes in. That's what I'm trying to accomplish, okay? So when I specify delta of epsilon, I say for this thickness, okay, this thickness on the domain doesn't work, this does not work, but this works, okay? For this thickness, this does not work, but this works, okay? So I'm trying to you just adjust. So somebody adjusts the target pipe, you know right away how to adjust the domain pipe. Make sense? That's the entire idea. So a few people solved it. Let's do it again. And here is the second part of the idea, guys. The second part of the idea is we pretend that we have not been looking at the x-axis at all. We were just closing the valve. You might have done that when you're brushing your teeth. Maybe you're closing the faucet. You're closing the valve, and and suddenly you realize the current has been made thin enough. So basically here you're saying the particle, that is some arbitrary particle that I paid attention to, that was launched at position x. It arrives on the y-axis at position 5x plus 2. And I noticed that its distance from my intended target from -8 is less than epsilon. Make sense? So this is doing the same thing, but blindly, because you don't see the graph, you don't see the current, you're just being communicated this information. It's very similar to when you're trying to land a spacecraft on let's say Mars. You see, you cannot see it in real life. You receive signals or information, you have to be thinking blindly entirely. Make sense? So it's a very similar thing. So it's a communication. You were closing it and suddenly you hear communication. Particle, 5x plus 2. The particle launched at x, landed at 5x plus 2, and its distance from -x, this means this, was less than epsilon. In other words, what this means, what this part of the sentence to me just reads, particle entered into the target pipe. You understand? So instead of reading all those complicated formulas, I just understand it, aha, particle landed in target pipe. The question is then, what was my domain pipe? And the answer in terms of those symbols will be, what's the distance of x to -2? Or what's absolute value of x minus 2 like? X plus 2, okay? Make sense? Are you with me, guys, right? I'm explaining, I'm making perfect sense to myself, but maybe I miss you entirely. Like with I'm using the wrong delta for you. I hope I'm not. Okay, Rafim, so let me just verify. I'll just write got it. And now write, yes, I understand everything you said so far. Just write yes, or just Y even, right? Type Y.
Before I write yes.
Yeah, you don't need to. I'm not forcing. Don't write yes, you write no if you don't understand something. Go ahead, Carolina.
So when you, in the solution, you're subtracting -8 because you're saying that that arbitrary value lands within the range, but
Yes.
I'm not sure how you got there, and I don't know if that's a stupid question.
Exactly. Well, so you might actually, you're exactly on the same place. So Zohaib, when you say explain the theory, I might go over that again, but do you understand what I was repeating about the input pipe and output pipe? You have to, you see, guys, I can tell you this. You see, there are many things that I read, many things I think about, and the only thing that I remember, that's why I can't remember people's names, you understand? Because most of your names are arbitrary to me. I need a strong connection why your name is something that makes very strong sense to me, right? So it's like maybe Indian names would have made sense, okay? In other words, something that your name captures about your essence, okay? Similarly with everything else. So with mathematics especially, the reason I remember this is that I understand it very easily. You understand? It's like you ask me what's the color of grass. This is just as easy for me as the color of grass, because I'm not thinking in terms of formulas. I understand what's the idea, at least on this level. Yes? And what's the idea? The idea is this, right? You are saying on the x-axis you plug in when you take limits C-like numbers, and the outputs are L-like numbers. Good? Now, how do you capture that idea mathematically? So you can capture it in terms of the pipes. Okay, I'll show the diagram again. Okay, guys, here is the diagram again. You capture it in terms of pipes. So my analogy is instead of shooting one particle at C, that's what you knew from before. Evaluation, you just evaluated that one water particle, right? What we do is we shoot simultaneously lots of particles, but not C. C is, there is a lead here. I'm not allowed to put C in, but I'm allowed to put numbers that are like C. Numbers that are like C means that I shoot an entire pipe worth, right? So not the table. And Alexa, you see that what's wrong with the table? Table only shows me it's like putting pebbles or putting some floaters onto the water, but I want to know where the entire water current is going, right? So what I imagine, I shoot this entire water current, and then I see it sprayed out of the gun, right? And I just note where it lands. Okay, so when I say, so I try to capture this idea again, guys. I'm trying to capture the idea in the limit that this current will get less and less wide, and will get more and more focused around the point L, okay? And I try to do it there in terms of pipes. You see, that means, what do I mean narrow around L? It means if you select a very narrow pipe around L, here I just drew it not so narrow, but the idea is select, no matter how narrow is the pipe around L, if I make the input pipe narrow enough, all the water particles will get into the red pipe. All the particles from blue pipe will get into the red pipe. Make sense? That's the idea. And you see, because think about it, right? It's very efficient way of measuring precisely what you mean by approximations of C and approximations of L. Because what you do with limits, you compare X going to C means X approximates C. Approximation means, in this case, the thickness of the pipe. The thicker the pipe, the worse the approximation. If the pipe is very thin, the approximations clearly are better because the X's are much closer to C. So delta measures approximations of C, and epsilon measures approximations of L. And you can think of them as pipes. Make sense? And the idea is that that close enough approximations of C will produce close enough approximations of L. And by that we mean this: if I specify how good I want approximation of L to be, I will then adjust delta as a function of epsilon to be small enough so that every particle lands within this zone. Make sense? Very important idea, and maybe you will not see it so much in this class, but it's all the time how you communicate the precise ideas about limits. They're not always so easy as are in this class. So back to our problem. Here it is. You see, I cannot see the cannon. I'm blind to it. Imagine the cannon is somewhere else, and you just get reports, and the reports are done as follows, right? So imagine you were fumbling with the valve, the input valve. You're making the blue pipe thin, and then you are communicated the following: absolute value of 5x plus 2 minus 8 in absolute value is less than epsilon. What this communication means is that the particle launched at position x landed within epsilon away from -8, which means the particle entered the pipe. All it is that the particle that started at the point x entered the pipe. Are you with me? And the question is just like in this drawing: where did the particle start with, right? What was the size of the input pipe, of the blue pipe, where the particle started from, if it entered this pipe? So I need information about x plus 2. Okay, so then I simplify it, and I have that epsilon is bigger than 5x plus 10. I can factor out the 5, and then I divide, right? I divide because I want information how close is x to -2. Do you see that? I don't see absolute value of x plus 2. I really see the interpretation. This is how close x is to -2. That's distance. You know, that's how you measure distance on the ruler. So then I see that must mean that x plus 2, it's an absolute value, is less than epsilon over 5, which means that the distance between x and -2 has to be less than epsilon over 5. Which means what? Which means that in order to hit a pipe of radius 1 inch, I must make the domain pipe of radius 1/5 of an inch. If I want to hit within ½ an inch, I have to make radius of the domain pipe, the blue pipe, to be 1/10 of an inch. You understand? This gives me a precision on how narrow must be the input pipe. And since I can since I can do it for any epsilon, it means I can get the water focused enough to enter any pipe, no matter how narrow that target pipe is. Are you with me, guys? Alexa, you understand, right? So you understand how it works, right? Excellent. Think in pictures, guys, in imagery, right? In poetry, not in symbols. Symbols means nothing. It's like it's U, S, and E. If you see it as U, S, E, that means you don't understand this word. So this example I will skip. It's abstract. It's doing it for all linear maps, and we can calculate it. But let's go for a moment. We just again read the notes, guys. They're posted there. Let's try to see what you would say if I asked you to calculate, well, not to calculate, to prove using delta epsilon that as x goes to 4, x squared becomes 16. So the domain pipe at most, not at least, the domain pipe can be at most 1/5 the radius of the target pipe. It can be smaller up naturally, right? So delta of epsilon in this case specifies some pipe that would work. At most, the size of the input pipe has to be 1/5 of epsilon, 1/5 of the radius of the target pipe. If it's more, then you might miss. So now let's see what you would say about limit as x goes to 4 of x squared equal to 16. Don't worry if you don't answer it. Questions like this, they get harder and harder, okay? When you're ready, you can try telling me what.
Professor.
Yes.
I think I might have gotten it. I don't know if I'm right. Is it x plus 4, like parentheses plus 4, x minus 4?
When you factor it out, yes. Right. But what's the delta? So, you see, you what do you talk about when you do delta epsilon? You want to know what's the relationship between the target radius of the pipe and the domain radius of the pipe. Okay?
Okay.
The red is epsilon. The red pipe radius is epsilon. Okay, and it has to be so Rafid, they say x is less than epsilon plus 4. Let's see, guys, and don't worry if you don't get it right. See, I just want to see what is your thinking at this point. I would be surprised if anyone actually will answer it correctly at this moment, but I want to see your thinking. Okay, another answer here. So June says that I can make delta and epsilon the same. There is, by the way, not necessarily one answer to questions like that, right? There are many possible answers. All you have to do is provide a procedure by which you construct a comparison with the target radius and the domain radius. Okay, James says x plus 4 less than epsilon and x minus 4 is less than epsilon. What's delta? You see, no trouble, right? I hope you either will stay with me after the class is over. So one person came late, and either you stay or you watch this video, because I would really be glad if you understood delta epsilon. See, it gives me, see, like what do I have to dream about, right, guys? There's kind of my life is all in the back, all past. All I hope for is maybe, well, you know something because of me, right? That's pretty much that's all that's left. And another thing, maybe you will visit the cemetery with me, right? I'll show you where I bought my plot. It's beautiful. You don't know how it looks like, Greenwood, right? I will show you where I intend to be, or maybe where I am at night. Some people already think that that's exactly where I am. It's not far from you. Okay, any news? Anything else, guys? Any ideas? Always remember, right, guys, you don't want to give answers before you understand what is it that you are asked, okay? A lot of people, it's like a knee-jerk reaction, right? I'm not there to eat you, not yet. I cannot reach you right now, right? So your goal is not to answer my question first, but to understand what is it that I'm asking. So do you understand, first of all, what you are trying to find? Because if not, then your answer is completely unimportant, even if correct. Type in the comments if you're still working. So Alex says epsilon. Oh, thank you, Alex. Says epsilon x plus 4 and epsilon, but which one of those? You need to, you see, if you understand what I'm asking, then give me clear instructions, right? You are being like some sort of entitled woman. You know, a plumber comes and it says, make this toilet big but small, right? That's kind of what you do, right? Make it golden but silver, like gold but silverish, you know? You know what a plumber feels, what a poor, humble plumber feels when he has to deal with it. Hmm? Alexa, thank you. You say epsilon over x plus 4. That's very, very, very interesting. Very interesting. Guys, by the way, again, I'm not expecting that you will, at this point, answer correctly. Forget about the correctness. What is that correctness even? Okay? Ask yourself whether or not your answer makes sense. Anybody still working on this, or do we go over that together now? All right, we wait a few more moments. I just want to see if others are working with you guys. So if you're ready to go together, type R or ready. You can just write R since I know you're lazy. Okay, wonderful. Let's go over that together. So here is how many students begin this question, and actually we saw it now, right? So we would say epsilon is bigger than absolute value of x squared minus 16. Because what is this x squared? X squared is the landing of my particle. The particle landed at x squared, because that's what happens to any particle, it's squared, okay? And this is measuring the distance to the target. So suppose the distance to the target happened to be x squared minus 16. And we managed to put it in the pipe. You see, when I say epsilon bigger than it, it means that x entered the pipe. Everybody clear on that? So then I factor, it's a difference of squares. It's x plus 4, x minus 4, okay? And in absolute value, you know, the product of two numbers under absolute value is the same as the absolute value of each number separately, correct? Because I mean, what do I make? I make this positive. So I can make the first number positive and the second number positive and multiply them afterwards. Good? And thereupon, what we can do is, you see, we need information about the distance between x and 4, which is x minus 4. I don't like the x plus 4 part here, right? And as a few of you suggested, then I say delta of epsilon equal to epsilon divided by absolute value of x plus 4. And that has to be bigger than x minus 4, right? That must be my delta, right? Because if this, I just divide by x plus 4, and then we have x minus 4 is smaller than epsilon over absolute value of x plus 4. With this explanation, how many of you agree with this explanation, please? Type Y or something like this. Okay, so we all agree that it's perfectly correct solution.
Wait, I have a question, real quick.
Go ahead.
So when it comes to epsilon over absolute x plus 4, does it mean that like it's the singular answer, or does x minus 4 absolute 4 have to be also in the equation?
Well, I mean, maybe it's neither nor, right? We haven't yet agreed, or maybe we are just saying if we agreed, if it's correct or not, right? Before we see, there are so many questions to be asked. The first thing is I need to kind of have this moment of sanity and ask myself, do I know what I'm talking about? Good. If I don't know what I'm talking about, then I'll make more errors than the entire humankind can correct. Okay. So let's look at the solution, guys. Does this make sense? A bunch of you said yes, correct? Well, how many said yes? Yes. You know, I don't see 30 people that said yes. So not everybody is on board with me, right? Is that all? I don't see more yeses. Where are the yeses? Where are my yes men and yes women? Okay, well, look at this question, guys. What's happening to this pipe? If you define the pipe, epsilon divided by x plus 4. This pipe changes with the input. Is that what we communicate? Look at it, right? If there is x plus 4, then suppose I launch x equal to 4.01. Then it's epsilon divided by 8.01. Do you agree? Because 4.01 plus 4 is 8.01. So I have delta that's 1 delta for this x, and a very different delta if x is within the same domain. Let's see, if I have 4.001, I have deltas that change with each x. You understand? If you look at it carefully and you launch the particles, if you simulated, the pipe would just be doing like this. The input pipe would be wobbling. That's not what I want. I'm not going to replace you a new pipe for every x that you're launching. I want one pipe. The fact that you made it depend on x makes it absolutely illogical. You understand? I mean, this is an entirely incorrect answer. Are you with me? Do you understand why it's incorrect, guys? Right? So just looking at it, you see, it's actually, I see the pipe moving. You see, you give me this answer, even if I don't know what's the right answer, I know it could not be it, because I see this. I see that your pipe is doing this. It's changing shape. It's not what's supposed to happen. It's supposed to be stable plumbing system. For this particular epsilon, I have to have a particular pipe, and everything in this pipe is launched into the pipe. Here, what you're doing when you divide by x plus 4 in absolute value, you're making the pipe smaller or larger depending on how close is x to 4. That's not supposed to happen. Do you understand? So this answer is absolutely incorrect. It should not depend on x. I did not expect anybody to get it right on this trial, right? But I'm hoping always that you read what's written. You understand? That you read about it and think about it. It should be intuitive. Otherwise, you haven't learned it. Here is the argument again, okay? So this is the trick that we can use here. So we don't want x plus 4 at all. We want a number, okay? So what we are going to do is we can insist the following. Since x goes to 4, I can make delta no larger than a particular value. I will choose delta less than or equal to 1. You understand? So I'm saying that because the input pipe is supposed to be narrow around 4, correct? It's supposed to be narrow. I mean, I could possibly use wide pipes, but here I will make the exclusion that I will never use a pipe larger than 1, larger than radius 1. I'm obviously able to do so because again, the idea is I use thin input pipes. Are you with me? So I will pick delta less than or equal to 1. What happens if x minus 4 is less than 1? I want to know what's the reaction of x plus 4 to it, okay? So if x minus 4 in absolute value is less than or equal to 1, that means x minus 4 is between 1 and minus 1, which means x, I just move in the 4 to both sides, between 3 and 5, which means x plus 4 between 4 plus 3 and 4 plus 5. Make sense? What I'm saying is this: if x is very close to 4, if x is within 1 unit from 4, then x plus 4 is between 7 and 9, which means absolute value of x plus 4 is definitely smaller than 9. You see, x plus 4 is a positive number, so in absolute value it's positive, and it's between 7 and 9. So I can see that x plus 4 is always smaller than or equal to 9. Are you with me? So here is how I reason, guys, you see? So then x squared minus 16, I just work it through. It's again x plus 4 in absolute value and x minus 4. And I can make it less than 9 times x minus 4. I make it a number. Why? Because if my pipe is smaller than 1, I know that this thing that I don't like here is for sure smaller than 9. So I'm making it larger by replacing x plus 4 by a 9.
How did you remove the side with the 7?
How did I do what?
How did you remove the side with the 7? The 7
because I need to find a number bigger than absolute value of x plus 4. I didn't remove anything, right? I'm just having an inequality here. It's not equality, right? In inequality, I can say an elephant is bigger than a fly. Even though actually, if you know the Russian expression, what's happening right now throughout the world is that a fly is being made into an elephant. Okay. Do you know what it means? To make a fly into an elephant, it means to make something small into something extremely significant. So what we have here is x squared minus 16. It's x plus 4 times x minus 4. Okay, but because I know that x is very close to 4, within 1 unit away from 4, that's because my delta cannot be wider than 1. I know that absolute value of x plus 4 because of this calculation. X plus 4 is always a positive number then, between 7 and 9. So that means I can insert absolute values here without any problem since it's positive, which means x plus 4 is always smaller than 9. Good? Bigger than 7, but I don't care about it. It's smaller than 9. So if I go here, I can replace the smaller number by 9. X plus 4 is smaller than 9, basically, right? So, or equal to it. So because delta is less than 1, I have the 9 here. And then here, I will also, and then for this part to be smaller than epsilon, it means that x minus 4 has to be less than epsilon divided by 9. You see, so I have two inequalities. My pipe has to simultaneously be smaller than 1 and smaller than epsilon over 9. So I set delta of epsilon to be the minimum of 1 and epsilon over 9. There is nothing unique about 1. I could have created a different function, which means that if my delta is simultaneously smaller than 1 and epsilon over 9, usually it will be epsilon over 9 because I would not usually like to use 9-inch pipes for the target. I might use it smaller. So mostly this is important, right? But this is just ensuring that my input is always smaller than 1. Good? So what happens if I use this delta? So if I use this delta, then simultaneously x minus 4 is less than epsilon over 9, which means 9 times x minus 4 is less than epsilon, that by property 1, because if x minus 4 is smaller than the minimum of those two numbers, it's therefore smaller than epsilon over 9. So this is true. And second part is that if x minus 4 is less than 1, then x plus 4 times x minus 4 is less than 9 times x minus 4. Good? In absolute value. I don't mention absolute value here, but you understand. Good? So again, this argument here, right? Look at it. So x plus 4 in absolute value times x minus 4 in absolute value by property 2. This part is less than 9 times x minus 4. And by property 1, this part is smaller than epsilon. So my proof is complete. Good. Let's see if you understood it. Here is the next problem. Can you see it, guys? Using delta epsilon, and it's, we see I'm giving you more complicated functions. Try showing that as x goes to -1, 2x squared minus 5x minus 2 goes to 5. Try to do it, please. Well, Victoria, the solution to this problem is your last name.
Professor,
Yeah.
I mean, I factored, I folded it out, and still kind of a little bit stuck. So wait, can I tell you my answer so far? Is that okay?
Well, tell me what you did, sure, if you want.
Okay, so I got absolute value of, so it's 2x, these are parentheses, so 2x minus 7, and then
Okay.
parentheses times x plus 1.
It's beautiful. Beautiful.
Okay.
Okay. Okay. And now what do you do next, guys, right? The idea was this, you see, you don't like which part here. So Alan and you, Alexa, you got absolute value of 2x minus 7 times absolute value x plus 1. Which of those two parts I don't want? They're not desirable.
Wait. Sorry, what was the question?
Which of the two parts, of the two product parts, are undesirable? Exactly, June. 2x minus 7 is undesirable. Because look at it, what must I figure out? Given that my particle, you see the proximity of the particle is 2x squared minus 5x minus 2, minus 5 in absolute value. That tells me 2x squared minus 5x minus 2 is where the particle actually landed. Minus 5 in absolute value is the difference between actual landing position and 5. And if I want to claim that the particle comes into the pipe, that means that 2x squared minus 5x minus 2 minus 5 in absolute value must be made less than epsilon, right? If I can make it less than epsilon, then I know the particle entered the pipe. So I pretend that I accomplished that. So what I can assume some things about the width of my input pipe. Because you understand, the input pipe is generally very narrow. I don't really care for the input pipe to be wide because x is close to, in this case, close to minus 1. Okay, so what I can do is like I did before in the previous example. I can say that, let's suppose that x plus 1 is less than 1. So I can, that means what? That means that I initially already know that there was no pipe that I ever used that was wider than 1 radius, 1 unit radius. Make sense? And so from there, I want to manufacture 2x minus 7. I want to see if absolute value of x plus 1 is less than 1, what does it imply about the maximal size of 2x minus 7? Make sense? So work a little bit longer and I will explain this. 2x minus 7, I want to, in absolute value, I want to replace it by a bigger number. Right, even if you understand the idea of plumbing, the actual practical application of it is very difficult, yes? That's exactly what we have here. In a moment, we will do it together, guys, but did you follow what we said so far? 2x minus 7 times x plus 1 is this thing, this expression. Good? When you're kind of too frustrated and ready, we can talk about it. Yeah, very similar example, I think. Okay. Okay, so it seems like you want us to go together over this example. Am I right? No. Okay, good. I'm glad that no, you want to solve it. Okay. Okay, good, Alexei. You notice it cannot be the answer because your pipe is so thin, it's negative. It has negative length. It reduces distance to, it's very, very clever pipe if you can invent such a pipe, right? 7/2, it means that you are using the same pipe no matter what, okay? Let's, 7/2 means your pipe is 7/2 inches wide. Now, so here is the argument. And see how I figure it out, okay, guys? So first of all, we assume, well, this is going to be a last stage. I'm just we just want to investigate what's 2x squared minus 5x minus 2 minus 5, which gives us minus 7. I factor out x plus 1 and 2x minus 7. X plus 1 is the distance between x and 1. I will need information about that. Good? So what I'm first supposing is that x plus 1 will be smaller than 1, which means all the pipes I can use around minus 1. The biggest pipe I have is of radius 1. Does it make sense? I just decided that in my toolkit, in my plumbing toolkit, the widest pipe I have is of radius 1. I could have decided that the widest I have is radius 1/2. It doesn't matter. In this case, it does not matter. I'll show you below where it might matter, okay? In general, the pipes that I'm using are going to be very thin. Make sense? Because x is usually very close to minus 1, so the pipe will be thin. I might as well suppose that all the pipes are less than 1 unit. So that means that if this is true, this is a number less than 1, which means what's the number on the inside of the absolute value? Anything between 1 and minus 1. Do you agree? If absolute value of a number is less than 1, then this number is between minus 1 and 1. No matter how it looks like, if I take absolute value of any number and it's less than 1, the numbers I have here are anything between minus 1 and 1, correct? So my goal, I don't care about x, I care about 2x minus 7. What's a number bigger than absolute value of 2x minus 7 for all points that are launched near minus 1? in the white pipe, you understand? So in the white pipe, what I have is then x is between -2 and 0. I just subtract 1. And that 2x minus 7, I multiply this by 2 and subtract 7 is between -11 and -7. Good? Do you understand how I get those numbers and why I manufacture 2x minus 7? That's the part that I want to know in absolute value, how big can it be? So I realize the 2x minus 7 is between -11 and -7, which means absolute value of 2x minus 7 is necessarily less than 11. You agree? Because this number is between -11 and -7, which means this number in absolute in magnitude can never exceed 11, right? The number never moves on the positive or negative in the positive or negative direction beyond the mark of 11. So that's my my width. So it's less than 11. Good. Go ahead, please, Zoe, to speak.
Yeah, Professor, you see where the first part, it says -1 is less than x plus 1 is less than -1? Why is
-1?
wait, scroll down. Yeah, right there on the solution.
Okay.
See where, yeah, the first one right there.
Yes.
Why is it giving the parameter of -1 and then the other one is -1 also?
Well, because think about it, right? Suppose you have a number, and it's what is the absolute value? If you just call this number y, call this number by any letter you like, so you don't think about x plus 1. It means the distance of this number from 0. Here, maybe I'll write it so that you would see it better. Let's say so. No, where is it? Strange. Wasn't there an ability to write? I think there was, right? Line. Or maybe they removed it. There was, well, it's whatever. You see this thing where I pointed? Imagine it's a number. So this means the distance of this number from 0 is less than 1, which means this number is no farther than 1 unit away from 0, which means this number is between -1 and 1. Do you agree? X plus 1 is a number. Absolute values represent 0. So you can say, you think of it as a number minus 0 in absolute value. So this number is between -1 and 1.
So that's why you keep it -1 on both sides and not positive?
No, 1, there's a -1, and this is, I accidentally wrote something that looked like a minus. It's supposed to be just 1, right?
Oh, okay.
-1, there is no minus. I was hoping nobody would notice, right? So it's -1 and 1. They're not both negative, right? No, it's -1 and 1 because the distance of this number from 0 is no more than 1 unit.
Right. Okay.
So the number is between -1 and 1, which means if I subtract 1, I get on the right, I get 0. On the left, I get -2. And then I multiply by 2 and subtract 7, and I get the bounds -11 and -7, right? So 2 times that is 4. So it's -4. -4 minus 7 is -11, or 0 minus 7 is -7. So the 2x minus 7 is a number between -11 and -7. It never goes below -11 or above -7. And so in absolute value, what's the distance of this number? What's the biggest distance of this number to 0? It's the distance of this number to 0 is always less than 11 units. In fact, you see, it's always on the left. It's a negative number, and it's no farther than 11 units away from 0. So I pick that absolute value. So I know that 2x minus 7 is less than 11 no matter what, if x is within 1 unit away from -1. Okay, and now this is what I can do. So now x plus 1 absolute value times 2x minus 7 absolute value will be less than 11 times x plus 1, assuming that my input is less than 1. Delta is less than or equal to 1. And then 11 times x plus 1 will be less than the epsilon, assuming that x plus 1 is also less than epsilon over 11. You see? X plus 1 in absolute value has to be less than both 1 and epsilon over 11, which can be summarized as delta of epsilon can be written as the minimum of 1 and epsilon over 11. You're with me? So if mostly it would be the second number that matters, because epsilon usually will be smaller than 11. It will be usually smaller than 1, right? But this just means that I'm assuming that I'm over. For example, if epsilon is equal to 12, I'm not going to use 12 over 11. I'm going to use the widest input pipe I have, which is 1. You understand? So this tells me how to use it. If epsilon happens to be 11, I can use 1. If epsilon happens to be 9, then I use 9 over 11. If epsilon is anything smaller than 11, I use this part here. But this works, you understand? If I make my pipe smaller than both, the input pipe smaller than y and epsilon over 11, I accomplish my goal. With me?
I have a quick question.
Go ahead.
So what happens, because I did something stupid, but what happened was that what happens if you won't get something that's easily factored, like 2x minus 5x minus 4? Do you still have to factor that?
Well, you see, we're going to move beyond that. You see, delta or epsilon arguments are not useful for such questions at all. I can make it x cubed. It's possible to factor it, and it might be more difficult to figure out the answer. It's possible to do it, but that's not what delta epsilon are for at all. I'm trying to illustrate the idea. You understand, guys? I just want you to understand what delta epsilon are doing, but you see, if I were developing it, I would never apply delta epsilon for any of the examples. I did. I know they're true because of limit laws. And the goal is to prove those laws, you understand? Okay? The goal is to prove delta, the limit laws. Why are they true? If I prove that the limit laws are true, let's say if I prove that the addition and subtraction law and multiplication law are true, then this will be a bunch of applications of the addition, subtraction, and multiplication laws for the limit laws, and then I know, right away know without this what works. And unless, of course, you are trying to deal with approximations, you understand? So delta epsilon is in a way numeric approximation, how to work with a particular machine, how good of an approximation you need, and then you need this theory as well. You understand? Because it's very, let's say if you construct a machine and the machine is not going to calculate root of 5 precisely, right? The machine cannot calculate root of 5 precisely because it's an irrational number. So when you press in your calculator root 5, it spits a bunch of digits. And if your calculator is, no matter what calculator, it just gives you some number of digits. So a typical scientific calculator gives you, let's say, 8 digits. Do you hear me? 8 digits, you see 8 digits after the point, right? So that means that your epsilon, your ability to recognize whether a number is root of 5 or not, is 1 over 10 to the minus 9. So 1 over 10 to the 9, sorry, right? For example, right? So you can, the 9th digit, you cannot tell apart. You understand? So that type of thing. All right, so I'm going to skip this. This is a general proof that any quadratic at any value will give you the same value, the same thing as if you just plug in the value. Okay, so I carry out here. You can look at the argument. So one thing that you should wonder about is, why did I pick 1, for example, right? It was arbitrary in some situations. I could have picked, for all previous examples, I could have picked delta less than 3, and that would still, I would construct some delta argument, or less than 1/2, or less than 100, I would still be able to construct some delta. There is no unique delta. Delta just means if the input pipe is this thin or thinner, then the current goes where I want it to go. It goes into the red pipe, okay? Let's try to see what to do in the case where I take limit as x goes to 1/2 of 1 over x. I want to show that this equals to 2, okay? So in this case, look at it, right? In this case, I cannot plug 0. So my interval has to be, my input pipe cannot be wider than 1/2. Understand? So not all deltas will work. I cannot take delta equal to 1, or even delta equal to 1/2 is bad because I will have this terrible point here. Make sense? So my delta should be, maybe I can select delta is less than 1/4. So for this, I'm going to work with deltas that are 1/4 or less. Are you with me, guys? So let's see, guys, any questions before I continue? Are you following the new example, type Y, if you follow what I'm saying?
Can you go over that like one more time?
Sure.
Okay.
So you see, in the previous examples, I said you could have picked delta smaller than or equal to 1, but that's not always going to work. So for example, suppose I'm dealing with, I want to use delta epsilon argument in dealing with 1 over x, where x goes to 1/2. Good? So the limit here will be 2. How do I know that using delta epsilon? Well, I cannot pick delta because I'm at 1/2. I cannot pick delta that will include 0, because 0 I cannot feed into this mechanism. Okay, so my delta has to be smaller than 1/2 at least, right? So I'm not going to use pipes wider than 1/2. In fact, I can restrict and say I am not going to use pipes that are wider than 1/4. You can do more than 1/4, but avoid basically this point. Okay, 1/2 is the widest pipe I can use at 1/2. You understand why, right? So here it matters. So I'm gonna, for this problem, I'm gonna assume that delta is less than 1/4. So then I begin 1 over x minus 2. Well, I can combine, and I can write it as 1 minus 2x divided by x. And I want to figure out distance of x to 1/2. In other words, x minus 1/2. So what do? I'm going to factor from here minus 2 and from the denominator x. So I factor out minus 2. And what do I get? Minus 2 here, it's minus 1/2. Sorry, 1 times minus 2 is apologies again, right? So when I factor this minus 2, you see that I get x times minus 1/2, right? If I factor the minus 2 from x, I get x. And if I factor it from 1, I need to multiply minus 2 times minus 1/2 to get plus 1. So I get this expression. It's minus 2 over x, all in absolute value. And then I take absolute value of 2 divided by x times x minus 1/2. So I have to manufacture and replace 2 divided by absolute value of x. And so I begin, okay, x minus 1/2 in absolute value was less than 1/4, which means x minus 1/2 was between 1/4 and minus 1/4, correct? Which means x, I just add 1/2, it's between 1/4 and 3/4. And so when I take reciprocal, right, reciprocal of 1 over quarter, if x is bigger than 1/4, reciprocal will be smaller than 4 and bigger than 4 over 3. Good? You see how I do? I'm manufacturing, I don't need even 1 over x, I need 2 over absolute value of x. I'm manufacturing bounds for this expression, which I don't like. Good? So then I multiply by 2. 2 over x is between 8 and 8 over 3, which means absolute value of 2 over x is smaller than 8. Okay, and so now I can carry out the estimation. So 2 over absolute value of x times x minus 1/2, which equals to absolute value of 1 over x minus 2, right, is less than 8 times absolute value of x minus 1/2. Under what condition? Under the condition that x minus 1/2, the width of the input is within 1/4. So the widest pipe I could use on the x-axis was 1/4. That's how I get this 8. And this is less than epsilon under the condition that x minus 1/2 is also less than epsilon over 8. So I get my delta to be minimum of 1/4 epsilon over 8. Okay, so those are all calculations which I hope you train to use them. They are not the calculations for which delta epsilon is useful for, at least if you're doing it in just theory, if your goal is to find what's the limit. If you're doing calculations, it is important because you need to be sure what's the tolerable error. You see, many things cannot be calculated precisely. Delta of epsilon arguments can give you a way to, like an engineer, to talk about tolerable errors. Okay, so somebody tells you tolerable error is 0.0 millimeters, which means that's your epsilon. Your epsilon is equal to 0.01 millimeter. Okay, that's where in engineering you talk about it when you're designing some certain things. Okay, so for all the equations we have considered thus far, delta epsilon is not, is not the thing to go. If I wanted to just prove that limit as x goes to 1/2 of 1 over x equal to 2, I would not go through this argument at all. Okay, here is what I want from it, right? And that's actually a true test whether you or not you understand delta epsilon. I will give it as extra credit on your exam. And I will possibly give it in such a way where you will have to think logically. Understand? It's not going to be a calculation. You will just have to realize based on some information, like what I show you here, for example, right? So suppose that here is the addition law. Suppose that we know that limit as x goes to a of f of x is L, and the limit for g is m. Then we want to show the addition law, right? That the limit of the sum is the sum of the limits. Okay, I'm proving one of the laws of delta epsilon. Good. I might not get to the proof today since our time is almost over. As they say in German, unsere Zeit ist knapp. Our time is narrow or short. One important inequality that we want to talk about is called triangle inequality. And triangle inequality is just a way to say that the shortest path from point A to point B is a straight line, at least in this geometry, in Euclidean geometry. Okay, so this you know intuitively. Look at it, right? If you go from A to B and you decide to segue to point C, it looks like it's a longer distance. That's why it's called triangle inequality. But it works also in one dimensions. Okay, so here is the triangle inequality. One moment, somebody screams to go out. If you want to see him, by the way. Okay. Okay. Did you hear the screams? Yes. So here is the situation. Okay, so imagine that you're traveling on the x-axis from point A to point B. In this case, let's say to the right. Okay, now you can select a point in between, C1, and of course, going to that point does not affect your distance, right? But if you select a point C, so in other words, you first go here and then back to B, that will make your distance longer. Do you agree? You understand? So that's illustrated. This is in 2 dimensions, but we are dealing with the triangle inequality in 1 dimension, right? So basically, if you visit position C, either your distance is the same or the distance is bigger. You travel either more, or if your goal is to go from A to B and you visit an intermediate point C, in this case, if it's along the path, your distance is not, your trip is not made longer. But if it's outside of the path, then your distance is made longer. Or in here, you see, if you go from A to C and then from C to B, your distance can be made longer. So this is, I'm going to show with a proof, but the distance that you travel from B to A is absolute value B minus A, correct? Which either, in this case, equals to the point in between, the distance between C1 and A plus the distance between B and C1, which is the full trip, or it's exactly smaller than the distance between C2 and A and B and C2. So at any case, absolute value of B minus A is less than or equal to C minus A plus absolute value of B minus A, which means a triangle inequality. To go, the distance between B and A is smaller than the distance between A and C and between B and C. Okay. I might actually stop here because I already see one person is yawning, so I possibly overcooked your brain. So we will continue with this topic again. We will finish it on Thursday and do a few other things. Sounds good? So I hope you learned something here. And if you want to have questions, then just ask me. I will stop recording the video and you can talk to me if you want.